Hi, so this is me again, Shefi. I'm going to solve another problem from the CodeWars with Python. So this is a very interesting question, and it took me some time to reach the solution I was happy with. So the idea is like this. We have triplets here, which are basically sets of 3 letters, and the sets of letters is the order of these letters inside what is the secret. The secret is a certain word, a phrase that we try to find out. The other rule is that the secret has each letter can only appear once. So through these triplets, we should be able to reinterpret the secret. So let's see how we can reach that. So basically, at the beginning, I thought how I can go over the triplets and like collect one by one and basically build the whole secret. But the thing is, after thinking a bit about it, this whole idea, this whole question is basically about sorting. We actually have it's kind of like an array of numbers, a list of numbers, which is unorganized. But the thing is that instead of having numbers, we have in the order of the letters. So we really want to just sort the letters in a way that will create the secret. It also means that we can actually create some kind of a permutation of the secret just by putting all the letters together. And so how can we do that? So let's start with this. So this is the name of the function, and first of all, if there are any letters here, if there aren't any triplets, we can just return empty. And I'm not sure if this is needed, but just in case. So if not triplets, just let's return the empty string. Okay, so that handle. Now I want to get let's say getting all. This is not a comment of C#. This is a Python comment. So again, all the letters. So basically, I'm going to create a set. Okay, so I'm creating a set with 4 letters, and for every set of letters, I'm adding it. So for every triplet, every subset of the letter, so every triplet in triplets, I'm just going to say letters dot update. This is the method that used to add the values to a set. So I'm just going to add the triplet. If you haven't had a chance yet of working with set, the whole idea with set is that the set is like a list, but it can only hold each member once. So it can only, so even if we have like a few triplets that have, for example, here we have 2 of them that hold the letter S, and also these 2, still the letter S will only appear at the set, will only be added at the first time. So once we finish with this loop, we'll have all the letters inside this letters set. So this way we have all the letters. And now let's just create an array, a list that will hold all the letters, and this will be our starting point. So this actually took me some time to understand. This is probably the best way to do so. So once we have the array, my thought is like this. I'm going to go over the triplets, and each time for each triplet make sure that the letters in the triplet are in the right order. And the thing is that it takes a few iterations. So every time I'm going all over the triplets, I will check if I have made any change. If I've made the change, I will go another time. If I haven't made any change, then this will be my signal that everything is fixed, and I can leave it at that. So for order to know if the array has been changed, I will just create a flag here. I'll call it change, and it will be set to true. So I'm setting it to true actually so I can use it inside the loop. Okay, so I want it to enter the loop at first time instead of doing like do while. I'll just do it with a while. So while change. Okay, I want it to go over the loop, and inside the loop I'll start with change equal false. So this will make sure I will enter the first iteration. And next thing, I thought about at some point I used count just to count the number of iterations, but you know what, I'll go for this simple solution here. So I'll just check if it has been changed. So now once the flag is set to false, I'm going to go over all the triplets. So for that I have this for loop, which is basically a for each loop. So for each triplet, it's about the same. It's actually the same as this. Okay, so for triplet in triplets. Okay, so what I'm going to do here is I want to find the indexes of the letter from the triplets. So I'm using this mark, so I'm going for the LI for left index, MI for middle index, and RI for right index. So for each triplet, the left index is the first one, the middle index is the second one, and the right index is the third one. So basically it's like this. So LI equals array dot index. This will give me the index and the array of the letter. And because we created the array with all the letters, we know it's somewhere in there. So it's going to be the index of triplet, the place 0. So this is the first letter of the triplets. And I will, I don't have the shortcut E to duplicate the line, but I'll just copy it. Okay, and this is 1 and 2, and this is the right index, and this would be the middle index. So of course this I don't really know at this point if the letters are in the right order. So what should be the left index here actually might be the max index or something like that. So after that we have to rearrange them. Okay, so after getting all these indexes, we have to make sure they are in the right order. So let's see if they are in the right order. It's just a simple thing. So if they are in the right order, or let's say if they are not in the right order, then Li, which is the left index, is not the minimum of these three. Okay, so Li, Mi, and Ri. Okay, so if the minimum should be Li, but if it's not, then we know we have to go inside and change between them, swap between them. And also, so if this different than the minimum, then left index is different than minimum, and also, so or the right index is different than max. So if the max value is not the right index, so the max from Li, Mi, Ri again. Okay, so if this condition is true, which means that Li is not the minimum and Ri is not the maximum, and of course if Li is the minimum and Ri is the maximum, Mi must be in the middle. So just a second. Okay, so again, so we check that the Li is not the minimum or that I is not the maximum, and in this case we do need to change between them. So how do we change? So I'm going to do a small trick to find the exact index. So let's say first of all I know that Li will be the minimum and Ri will be the maximum. So I'll just copy paste this and use it. Okay, so Li will be the minimum and I will be the max. That's great. Now I want to find the middle one, and how would I do so? So I can use this trick. So I'll use this trick. I'll create a variable called sum, and sum will be actually the sum of Li plus Mi plus Ri, and that's because that's if I do something like this at the end, I'll put middle index equals sum minus Li minus Ri. Okay, so it goes like this. Because sum is all of them, when I do sum minus the minimum and the maximum, Li and Ri, I'll get the middle one, okay, Mi. So this is great. I'll have this way I have now each index variable has the right index, and now I can just put the right value in the right place. Okay, so basically why I have to do so, the array on the left index should be the right letter on the top, sorry, the left letter at the triplet, sorry. Okay, so this is 1, and this is 2, this is 3, so he will have 1 and 2, and he will have right index, and he will have middle index. Okay, so this is great. This is actually all we need, and here we ordered, we made everything in order. Of course, this should just be indented inside here, because this should happen for every triplet inside triplets. Now, what's missing here is we need to change the change to true. So if this happens here, okay, this also should be actually inside, right? Okay, so what's missing here is that change should be equals true, because we did change the order of the letters. So if we change the order of the letters, and after I finish with all the triplets, I want to do another iteration inside this loop, which will actually go again over all the iteration to make sure that we do look, each triplet might, because of the order, then after, like for example, doing this triplet, we might need to do this triplet to make sure the letters in the right order. So there is possibility that we have to have a few iterations to make sure that we get all the letters in the right order. So the only way for us to know that we have finished if we go over all the triplets and nothing has changed. So the change that has changed here to false will remain false, and in this case it will not enter the while loop again. So after we finish this, we just need to return. Okay, so we just need to return the secret. So we can return we use this with join. So this is like the limiter, and we do join, and we give inside the array. So this will give us the array as a string, the array of letter as string. Okay, great. So actually the array of the organized letter string. So let's have a look and test it. So this is the basic test. Okay, and the test had passed. That's amazing. And let's attempt to do all the other tests. And it works. So of course I have here my reference, and I actually did another thing. I tried okay, so now it offered me, it's interesting, it offered me to refactor, but this is nice. So I just want to talk about another solution I thought about. So after that I wanted to try another solution, and what I thought was, because I understood this is basically a sorting problem. So what do we know about the sorting? So I thought about it, and actually if I took the only letter that appears in triplets on the left side and not any other index cell, then it has to be the most left letter, so the first letter. And if I continue like that, I will have I can find all the letters just by sorting. Now what's happening is, if I find this letter, I will remove it from the first index from all the triplet, and then I will take the next letter. So let's kind of do that, just so how it would work. Okay, so let's say I'll do it in comment right here. Okay, so let's say I have these triplets, right? So let's look at the letters. So T is the first one here, but it's not the first one here. W is the first one here and the first one here. and nowhere in the middle or in the end. So let's say I'm just going to take W and I'm going to remove it from here, okay, and here. So basically the logic here is that the smallest letter, the left letter, would be before any other letter, and because of that it will never be in an index in the middle. So after I did that, I would look for the next letter on the left. So T we still have here. How about H? A we don't have here or on the right, and we have it here and here, so let's take H. So I'm taking H and I'm just removing it from here. Okay, so I moved it from here and here, so I got the H. Let's see the next. So T is still in the middle here. I got here the I. I also got I here, so it's not going to be I. T we said didn't. A we got here. We don't have in the middle on the right, so A is the next one. So I will move the A from here and here. That's nice. And let's see, now T is actually on the right, finally. Okay, because we have it here, here, and here, and now in the middle or in the right, so let's just take T. So T, let's remove it, remove it, remove it, and this one as well. That's really nice, right? So we have what already? And let's see, we have U here, but U here, so U is not the next letter. We have I here and I here, and no I in the other indexer. So I is here. Let's remove it. Remove it. Next one we'll have. Okay, so this one can be totally removed. You have U. We have U here, but it's also here, so it's not going to be U. But as we have only, as we have here, here. Hey. We didn't remove the H from here, so basically yes. The S is the next one, so S is here. So this is already gone. This is gone, and this is gone. So now I only have U and P is the last one, so it's going to be U and P. And you see this algorithm is also working. Actually, did the programming of this one, and okay, I think I'm going to skip showing it to you. No, I'll just show you this on PyCharm. So this was the first function I wrote. Okay, and this is the second function. Okay, so this one does the whole idea of I'll just maybe enlarge it a bit. Okay. So basically this function is a solution of always taking the first letter. So you see here, for example, it's just like moving them to the left. The letter, once I move the letter, and this is if I found the letter in more than just the first place. So I mark the found left as false, which for each letter I mark it for true. Okay, and I think that will be enough. But I actually did a count and tried to find out if one algorithm is better than the other, and it's actually in different cases. But I do believe that in most cases, using the triplets as a, like a swapping mechanism is better, because every time we use it, we actually order 3 letters. But not totally sure. I did try another, how I created this one, secret and the triplets, just by trying them, and it actually works. So you know what, I'll just show you the result of running this code. So run this code. Okay, so let's see. So I got the what is up. In the first algorithm it took 28 loops, and the second took 17. And with the lazy dog sit up, the one I created, so it took 48 in the first one and 41 in the second. So the second was actually shorter. So I'm still pretty sure that the first one will work better, but you know what, I can actually, let's try and check it. So let me just take this other function, okay, and put it back to Okay, let's just try it out. So, sorry for noise. So let's say I'm just taking all this. Hopefully I'm not screwing anything up. Okay, and here it has more printing and everything, but basically it's the same thing, only I need to remove this too. So let's test it. And you see that it's working. And it's did it with a count of 18. And let's attempt it. So we have few of them, 23, 29, 29, 13, 175. It passed all of them, so you see both algorithms actually work. Now I want to remember the exact number. Okay, so the last one may be most interesting, 175. So let me try doing that with the first function, with the count. So it's a lot similar like what I've shown you before, and it's just also counting the numbers. So let me see, let's copy it right here, delete it, paste, let's test it. Okay, so 42, and run it. Oh, and the last one is 1422. So I guess it proves my intuition was right. This is actually, I think it's the order of all the letters. So from A to Z. So the more letters we have on the secret, the better is the first algorithm. So this is my assumption. No, actually the first algorithm took more time, right? That's interesting. So it's actually better probably to do use it like sorting. So let's just to make sure, I'll try it again. I'll take this one again. That's really interesting. So it seems like it's better to use a kind of sorting. Okay, so always look for the left one. And it's really interesting a bit, actually. So I'm using this, and I'm testing it. So the first one actually seems right. So the first one is 17, and when I try all of them, yeah, much better. Much better. Okay, that's really interesting. So thank you very much for joining me. I hope you enjoyed this kind of tutorial and lesson. And let's just talk about a few pointers. So this is basically a sorting. Okay, so this is a sorting question. And in the same way as sorting, preparing things in advance, like putting all the letters, is actually, here I didn't do that, but when all the letter works out, right? So it's really, I guess just what I'm saying, just okay, we can think of it as sorting. We can swap the letters around. We can just find from the minimum one, but this is, it looks like much more complicated question. It is kind of complicated, but it's basically just, changing letters position. And the thing is that this can probably be translated to numbers, right? So, like, okay, we can translate it to numbers in a way, and then it's like sorting number basically. Okay, so I hope this helped you thinking about it in a bit of different way, and maybe understand something about maybe how to use Python or how to solve this kind of problem just by watching, I guess, me do it. So thank you very much for joining me, and I hope you enjoyed it, and I hope to see you on the next video. Thank you.